This is going on page 114 when we are done. Yesterday we converted coordinates. Today we are going to convert equations from polar to rectangular. Because remember, we can graph the exact same graphs and shapes and whatever in both, but their equations will look different because clearly their grids are different. Well, we'll talk about that when we get to polar. Never mind. So we're going to start by converting our rectangular, the x and y stuff that we are more comfortable with, to polar. So we're going to recall, meaning that we already know this because we did it yesterday. X equals r cosine theta, y equals r sine theta, and also that x squared plus y squared equals r squared. Okay, those basic things that we know are going to help us convert. And I'm going to take my jacket off because the sleeve ends up writing on the board for me, and I don't want it to. Okay. So in order to convert, we're going to substitute. So in place of x here, I can put r cosine theta. So I get r cosine theta equals -3. In the rectangular coordinate system, we a lot of times solve for y, not necessarily always, but in the polar, we solve for r. Okay, so I need to get r by itself. Since r is being multiplied by cosine, I'm going to divide. So this gives me r equals -3 over cosine theta. What's the reciprocal of cosine? Secant. So I get r equals -3 secant theta. And that's why when you have so we know that this is a vertical line in our rectangular coordinate system. This is also a vertical line in the polar coordinate system, would graph the exact same line. Okay, that's where it comes from. We good? All right, so on number 2, I could go ahead and substitute in something for y, but I feel like some of you might try and get rid of the fraction first, which is fine, and it may help us not do some weird stuff. So let's go ahead and do that. So I can multiply both sides by 3 and get 3y equals x times the square root of 3. Then I can substitute. What do I substitute in for y? R sine theta. Good. And for x, it's r cosine theta times the square root of 3. So I need to solve for r. So I need to get all my r's on one side. I can do that by dividing both sides by r. And when I divide both sides by r, they cancel out, right? And so now I just have a theta left. So just like we could have an x equals or a y equals line, we could have an r equals or a theta equals equation in the polar coordinate system. So the only variable I have left is theta, which means now I'm solving for theta. Okay, like I was trying to solve for r, r's gone, so now I solve for theta, right? Which means I need to get all my thetas on the same side. I could subtract them to make that happen, but I could also divide. If I choose to divide, should I divide by sine or cosine? Cosine, right? So if I divide both sides by cosine, I'm going to get 3 sine theta over cosine theta equals the square root of 3. Well, what is sine theta over cosine theta? Tangent. So I get 3 tangent theta equals square root of 3. I need more room here, so I'm going to make myself some room. Then I'm going to move up here. So to get tangent by itself, I'm going to divide both sides by 3. So I'm going to get tangent theta is equal to the square root of 3 over 3. And had I not multiplied both sides by 3 at the beginning, I wouldn't then have to go back and divide. But again, I think it helps you, some of you anyway, maybe all of you just in general, just helps you not have to reason through what to do with the weird fraction when it's there. Because I don't think it's that you're necessarily incapable of the fractions or the square roots, but a lot of times when the square roots are in the fractions, your brain has a little fizzle out. Sometimes you want to make it hard. So it's kind of better maybe to do it this way. So now I know that theta is equal to the tangent inverse of square root of 3 over 3. And what's the tangent inverse of the square root of 3 over 3? Pi thirds. And we don't have to worry about quadrants here. Pi sixths. Thank you. Sorry. Sometimes I just hear it, I'm like, yeah, that's it. Pi sixths. I just assume y'all are telling me the right things at this time. Pi sixths, because I was thinking about what I was going to say. We don't worry about quadrants so much. Obviously, if it was negative, then we would need the correct thing here. But because pi sixths, and we also have 7 pi sixths, they're both positive. Whether my equation is theta equals pi 6 or 7 pi 6, it's still the same line, right? So that's why it doesn't really matter. We'll just go with the reference angle and we're good. Okay. What questions you got? We good so far? Okay, perfect. So now we have y equals x squared. So y equals x squared. So for y, I can substitute in r sine theta. And for x, I can substitute in r cosine theta. And then it's squared, right? So when I square the right-hand side, because there's no addition or subtraction, then I can distribute that squared to both of them. So this gives me r sine theta equals r squared cosine squared theta. You understand how we write it like that? Okay. So again, I can divide both sides by r. I divide this, and it'll cancel out with one of those, right? So now that leaves me with sine theta equals r cosine squared theta. To get that r by itself, I mean, I could rewrite it, but y'all are okay without me rewriting that stuff, right? I'm going to divide both sides by cosine squared. So this will give me sine theta divided by cosine squared theta equals r. So I have solved for r, but I need to clean up that left-hand side a little bit. What is sine over cosine? Tangent, but that's sine over cosine squared, right? But I can use one of those cosines in the denominator, which will give me tangent theta times 1 over cosine theta equals r. Everybody okay with where all that came from? And then we don't want to leave any trig functions in the denominator. So what is 1 over cosine? Secant. So this is r equals tangent theta secant theta. And so on Monday, we're going to do this exploration activity. I'm going to have a paper for you to kind of follow. And then it's also tied to a Desmos activity. And that reminds me, Layla, I'm not trying to call you out, but I forgot to say something last period to somebody. I need you to go in today when we're done. I need you to accept the invite to Google Classroom. Like, you just need to go log in and it'll say, will you accept this, and do that. Because what I'm going to do is I dump the classes into Desmos, so like the stuff's already there for you. But when I assign it, if you're not already in there, it's a problem. So, and it's probably not even your fault that you didn't, anyway, we haven't used it in forever, I know. And you're not the only one, but just reminded me. So anyway, it's going to be in Desmos, but you're going to go through Google Classroom. I'll tell you all that on Monday. That's not even why I started saying this stuff, but I'm glad I did. I'm going to have you actually do specific things with some of the equations that we've seen, but then you'll also have an opportunity to just kind of graph some things like that and just see what it looks like, just for the heck of it. I mean, it's not like you have to know what the graph looks like, but you can see what doing different things what it does to the polar graphs. Okay, we good on number 3? All right, so on number 5, I would say again, so that we're not making things hard just to make them hard, let's get rid of the fraction. Let's multiply both sides by 5. So I'm going to get 5x equals y squared. So on this one, I'm going to skip this first step. I just wrote this so I made sure that you understood where this was coming from. But when I substitute in x, that's just 5 times r cosine theta. And then when I substitute in y, that's going to make that r squared sine squared theta. If you need to write this kind of stuff, that's fine, but I don't know that you necessarily need to. So then, modeling the same thing we did over here, what are we going to do first? Divide by r, right? So this r cancels out with that one. Trying to get r by itself, so I need to divide by sine squared. So when I do that, I'm going to get 5 cosine theta divided by sine squared theta. That's equal to r. What is cosine over sine? Cotangent. So I'm going to get 5 cotangent theta times 1 over sine theta equals r. And then what is 1 over sine theta? Cosecant. So this will be 5 cotangent theta, cosecant theta. What questions do you have? All right, let's look at number 5. What can I substitute for x squared plus y squared? R squared. So r squared equals 16. That's an acceptable equation for a circle, because I know in the rectangular coordinate system, that graph's a circle, this graph's a circle. We could say r equals 4. That's an acceptable answer also. It's not plus or minus, because when whether the radius is 4 or the radius is -4, it's going to graph the exact same circle, so we don't need them both. Everybody good with that? Okay, now on 6, I have an x squared and a y squared, but they're not being added. And when I put all my variables on one side, they're actually going to end up being subtracted. So this is going to be x squared minus y squared equals 1. So that's not r squared equals 1. So I need to actually substitute in for x, substitute in for y. So when I substitute in for x, I'm going to get r squared cosine squared theta minus r squared sine squared theta equals 1. Now, as I was explaining the next step last period, it finally, after all these years, kind of clicked with me why maybe sometimes y'all do weird things when you're factoring, when you're solving. Because I know the other day I tried to stress to you, if you're going to solve something, if you're solving an equation and you're going to factor, you cannot factor if it is not set equal to 0. And I keep thinking, like, why are we still making these kind of mistakes? Well, probably because in this case right here, we're about to factor without setting it equal to 0. But here's the difference. When you're solving, like I'm trying to solve for x, I'm going to get x equals 5. Like I know I have one variable, that's what I'm solving for. I'm going to factor and use my 0 product property. I can't use the 0 product property if it's not set equal to 0. So when I'm solving the equation and want to use my 0 product property, like x plus 3 times x minus 5 equals 0, I cannot factor until I set it equal to 0. In this case, yes, I'm solving for r, but I'm really just manipulating an equation. And that's the difference. Does that make a little bit of sense to you? And now that like I said, I don't know why it took me so long for that to kind of click, because I started thinking, oh, I factor all the time when it's not set equal to 0. But I'm factoring for a different purpose. Because y'all try and factor and then try to use the 0 product property, but it's not set equal to 0, and that's the problem. So I don't know if what I just said makes any sense to you, but as we go through, I'll kind of bring it up again just to make sure we're all clear so that maybe we stop making weird mistakes. They make a little bit more sense to me now while you're doing it. Okay, so with all that said, what do you think I'm about to do? Factor, right? Okay, so I've got, first of all, do I have difference of squares? I totally do. I have it here, and I have it here. I don't care, though. That's not how I'm factoring. Okay, but that does exist, and maybe if I needed to in a different situation, I have it, and I want you to be able to recognize it. But what I'm trying to do, I'm not trying to solve for theta, I'm trying to solve for r, right? So I need all my r's in one term, so I'm going to factor out my r squared. Does that make sense to you? So we're going to factor out our r squared, so r squared times cosine squared theta minus sine squared theta equals 1. And then I forgot at the beginning of this period, just like I forgot at the beginning of last period, if you have this card handy, grab it. If you don't, that's okay, because I didn't tell you you needed it at the beginning, and I'm not going to wait 10 minutes for everybody to take it out. But if you have it, then look on, remember we didn't do half angle identities and below, but see if there is anything that we can substitute cosine squared theta minus sine squared theta for. That's not my Pythagorean identity, right? What is cosine squared minus sine squared? Cosine 2 theta. Okay, if you hadn't found it yet, find the double angles. It might take you a little longer than that if you know, just to know what to look at, but I'm just not going to wait for everybody to find it. But look at double angles. Cosine 2 theta is cosine squared minus sine squared, right? So that means I can make this into r squared r squared times cosine 2 theta equals 1. Still trying to get r by itself, right? I'm going to divide both sides by cosine 2 theta. So I get r squared equals 1 over cosine 2 theta. What's 1 over cosine? Secant. So this is r squared equals secant 2 theta. And having r squared is okay. Remember the lemniscates? They had r squared. Like sometimes that's okay. Even here, like I said, this would have been okay, but you'll see it both ways. Okay. What questions do you have? Now, when you're doing these, don't go crazy trying to substitute everything everywhere. There will be very little substituting, if any. Okay, but in that case, it just made sense to do it. Okay, we good? I mean, let me take that back. Clearly, we're substituting a lot. I meant substituting from your trig identities. Be very little of that. Everything else is all substitution. Questions? Okay, so we're doing a lot more examples than we normally do in the notes because a lot of different things happen. So I think it's good for us to just kind of work through all these together. That's why I'm doing probably all of these, I think. All right, so let's look at number 7. Before I substitute, well, first of all, I know, and I know that in geometry you do this, and you may not spend a ton of time on it, but eventually we need to be able to recognize that at least this is an equation of a circle. Even if you wouldn't know exactly what to do with it, we've got the x squared plus y squared, and going from there. So that means in the polar coordinate system, it's going to graph a circle as well. But before I substitute, I want to actually square this out. And that does not become x squared plus 1. Okay, does not, right? If you need to write out x plus 1 times x plus 1 and FOIL or do whatever, that's totally fine. I'm just going to give you this one. I'm going to let you do the next one. So this becomes x squared plus 2x plus 1. And you don't necessarily have to write it out in FOIL if there's a process or like a shortcut too. Plus y squared equals 1. Now, I know that I can substitute things for x, x equals this, y equals this. But do you see anything else in there that might be helpful? Like that x squared plus y squared, right? So I'm going to put that together to move everything else over to the other side. So I'm going to leave x squared plus y squared here. And then I'm going to move everything, even if I didn't move it right now, eventually I would need to. So then that means I'm going to subtract 2x over here. And then these 1s just zero out. So that's what I end up with when I do that. And then what is x squared plus y squared? R squared. So this is r squared equals negative 2 times what? R cosine theta. Don't forget the r. Okay, r cosine theta. Then what would I do next? Cancel out an r. This r with one of these. So I get r equals negative 2 cosine theta. And that is an equation of a circle. All right, we're good. We're good? All right, so you multiply out number 8. Let me give you a minute to do that. And then I'll write it up there. Okay, once you get it multiplied out, check yourself with me. Let's make sure we agree, and then we'll move on together. Okay, we all good? So looking at the rectangular form, that's a circle as well. Just FYI, this is a circle. I can tell you the center is at -1, 0, and the radius is 1. This center is at 2, -1. The radius is the square root of 5. Okay, that's what it means there. So both of these are going to graph circles. We recognize this as an equation of a circle, right? It would look something like this, right? Over there somewhere, because it's negative cosine, and your diameter there would be 2. So it looks something like that. Okay, so let's go see what happens over here. So I see my x squared and y squared, so I'm going to leave this over here. X squared plus y squared. So that's equal to, I'm going to move my 4x over, so that's 4x, and then minus 2y. And then I have 4 and 1, which is 5. When I subtract that over, those numbers all cancel out. Okay. So now I can substitute. I'm going to get r squared equals 4r cosine theta, do not forget those r's, minus 2r sine theta. What do I want to do on the right-hand side? Factor. It's not set equal to 0, but I can still factor, right? Because I'm not going to use a zero product property anywhere. So r squared is equal to, now this is a case where, and it's fine either way. Me personally, I would factor out the CF and not the GCF, right? Because the GCF is 2r, which is fine. I could totally factor out 2r. But all I really care about is the r, right? So I'm just going to factor out the r. So I'm going to factor out the r, and that's going to give me 4 cosine theta minus 2 sine theta. So then, now I can cancel those r's out, right? The one on the right with one of the ones on the left. So I am left with r equals 4 cosine theta minus 2 sine theta. Now, based on what we have done with polar so far in that graphic organizer you have, I wouldn't expect you to just see this and recognize it as a circle, right? Because it doesn't look like the circles that we did, but it is. It just has a different center. It's moved differently. Okay. And again, you can play with that stuff next week. Or you can play with it now. I don't care, but you have to know how to do some settings in Desmos. We good? What questions you got? Okay, so now we're going to convert the other way. We're going from polar to rectangular. So to convert polar equation to rectangular equation, we're still using these same kinds of things, all that same stuff, right? But different forms of that can help me a little bit more, because what we know, since r squared equals x squared plus y squared, we know that r equals the square root of x squared plus y squared. And we know that theta is equal to the tangent inverse of y over x. And if we use those forms of it instead of these, that just kind of saves us a step in what we're doing. Okay, we're good with that? All right, so let's substitute. R equals 7. So I can substitute in for r. I can substitute in the square root of x squared plus y squared. That's going to equal 7. Then I can get rid of that square root by squaring both sides, so I get x squared plus y squared equals 49. This we should recognize is the equation of a circle whose radius is 7, right? And then this also, centers at 0, 0, radius is 7. We good? All right, so then theta equals 2 pi thirds. So theta is tangent inverse of y over x, and that's equal to 2 pi thirds. So to undo the tangent inverse, I would take the tangent of both sides, which means I get y over x equals the tangent of 2 pi thirds. What is the tangent of 2 pi thirds? Negative square root of 3. So I get y over x equals negative square root of 3, which means that y equals negative square root of 3x. And this is just a line, just like we knew that was a line, right? We good? Okay. On 11, have r equals 3 secant theta. So for me to replace a trig function, it's going to have to be sine, cosine, or tangent, right? Those are the rules that we have. Is secant related to one of those? Which one's it related to? Cosine. So r is equal to 3 over cosine theta, right? And I don't get to just straight up replace cosine. I have to replace r cosine, yes? Can I get r cosine out of this somehow? Yep. Multiply both sides by cosine. I get r cosine theta equals 3. What is r cosine theta? X. X equals 3. This is a vertical line, just like this is a vertical line. Okay, we good? All right, so cosecant. Don't have one for cosecant either. So that means r is equal to negative 2 over what? Sine theta. Then I can multiply both sides by sine. And y equals negative 2. Remember, all of this stuff came from a little tiny right triangle in the coordinate plane. Gave us the unit circle, it gave us all these rules, it lets us convert everything. There's just a ton with that little, who would have thought when you learned Pythagorean theorem how far it would have brought you, right? Pythagorean theorem and SOHCAHTOA, just it's the answer to everything. All right, now let's look at 13. 13, I have sine theta, but I don't get to just, I can replace just r. I can't replace just sine, okay? And if I divide both sides by sine, then I'm going to get cosecant, and then I'm in the same place I was there, but I'm just going to be going in this vicious circle. So when that happens, I need to create the r sine theta for myself. So that means I'm going to multiply both sides by r. So I'm going to have r times r equals r times 2 sine theta, because whatever I do to one side, I can do to the other, right? So I'm multiplying both sides by r. You don't necessarily have to write this step every time, but I want you to make sure you go back and look at this, you know where the heck things came from. So that means that r squared is equal to 2r sine theta. So now I can replace some things, right? What is r squared? X squared plus y squared. Equals 2 times what? R sine theta is y. Okay. This is why we needed to complete the square. And that's what we're about to do, because we're going to move this over and we need to make it look like a circle. So x squared is fine. There's no other x's. X squared is just going to stay x squared. Plus, then this y squared minus 2y. We're going to have to complete the square on the y's. So that means I'm going to have to add something over here. And then when I subtract this over, it leaves me with 0, and I need to add the same thing over here. Okay, that's what happens when you complete the square. And I think in Delta Math, it even had blanks that looked something like this. And I went ahead and put a 0 here because it is possible that that could be some other number. And I just want to make sure you know what's going on here. So I'm going to add to this, take half of that and square it. So I put a 1 here and a 1 here. And since I complete the square, I set x squared plus y minus 1 squared equals 1. And that's it. And there's your, this is a circle. The center is at 0, 1. Radius is 1. We good? Questions? All right. So let's look at number 14. Same issue, right? I have a cosine, but I can't manipulate by just dividing or subtracting or whatever to make it into r cosine. So I have to multiply both sides by r. I'm going to skip this step and just say that I know this is going to give me r squared minus equals negative 6r cosine theta. Then I can substitute, right? R squared is x squared plus y squared. That's equal to negative 6x. So this time I'm going to have to complete the square on x. Y is fine because it's just y squared. So this is going to give me x squared plus 6x plus something I decide on plus the y squared equals 0 plus whatever I added on one side, because whatever I do to one side, I got to do to the other. So you finish this one up. That is what you should get. Do we agree with that? Questions? Awesome. Then go ahead and get this taped in. I gave you your assignment.